Hello everyone, this video I'll explain question number 39 from practice final exam. Okay, so basically we're using Hess law again, but now we're calculating Gibbs free energy. Okay, so you should be quite familiar with this. Okay, but we'll just do it one more time. Okay, and then for this question, my strategy always I look at my final equation and see, right? This is my final equation, right? I want to see how I can get my reactants and products from the given equations. Okay, so that's how I'm gonna look into the question. Okay, so now let's start looking. Okay, so let me start from here. Okay, ClO. Okay, you go where I can get it. So yeah, you look at the following two equations. Just say that's one, that's two. You go, okay, so I only see it from equation two, but I want ClO as my reactants for my final equation. But from equation two, that's a product. You go, that's a problem, right? So how we're gonna solve that is we can just simply reverse equation 2, right? But before you jump in and do that, let's do an observation for the rest, okay? And let's see, we'll go, okay, so what else? We have ozone O3, okay? And then you go ozone O3 from the final, but it appears in both equation 1 and equation 2. That's a little complicated, okay? So we can leave it behind, okay? So let's deal with that later, okay? And let's see what else. What else is easier for us to deal with? You go, okay, so what else I have Cl, okay? That only appears in equation 2. I want it to be a product, but not as a reactant. I was going to reverse equation 2. By reversing that, I also get what I want for Cl, so that's good, okay? And then what's the last thing we have? That'll be what? That'll be this oxygen. Okay, so you go oxygen appears in equation 1 and equation 2. A little complicated as ozone, so we're just gonna now think about it for a minute. So let's do reverse equation 2, and then we get two things as we wanted. So we'll do that, then you have ClO, O2. I'm reversing equation 2, right? Okay, so I get Cl, ozone. Okay, so that's what we have. And then remember, whatever you do to the reaction, you do it to your Gibbs free energy for the reaction. Okay, so since I reversed, I'm gonna add the negative sign. So after this step, I get 34.5 kilojoule. Okay, so that's corresponding with this new equation. We already reversed. Okay, so that means we don't need to look at equation 2 anymore. Don't look at it. So we're gonna look at the new equation we have right over here, right? This is equation now we're gonna look at. Okay, and then you go, we have this, and then we already got what we wanted for this and for this, right? Now it's matching. So that's good. We have those two done. Now we need to see how we can get just one oxygen and one ozone. Okay, you go, but I wanted ozone on that side and two oxygen on the other side. You go, now what do I do? Then I go, let's look at my equation 1. Can I do something with my equation 1 and then get what I want, right? So let's write down equation 1. Let's take a look when we put them sort of together. Okay, so if you look, okay, I want only two oxygens on the right side. I have 3, but I have 1 from this equation on the left. If I add them up, what's gonna happen, right? Okay, so now let's try to do that. Okay, so we're gonna add these two equations up. Again, adding up we mean is what? You're gonna do that side and do that side. Okay, so we're gonna do that. Okay, so I'm actually gonna add them up, so I get 2 ozone plus ClO plus O2. Then I'll get 3 O2 plus Cl plus O3. Okay, you go, can I simplify this equation? Then you go, okay, I think I probably could. I have that, I have this. And then if I have 2 on the left, 1 on the other, that means we can cancel this out, right? Okay, so, oops, sorry, cancel that. Okay, so now I just have 1 oxygen on the left. I mean, 1 ozone on the left. Okay, and now let's see what else we can do. We have 1 oxygen, and over there is 3 oxygen. Of course, we can cancel the 1 on the left out, And then from 3, it's going to become 2 because you just subtract 1 basically from both sides. Okay, so now you get to this equation. Now let's take a look. What's this equation? Do a comparison with our original equation. Let's see. You go, wait a minute, they're the same. Yes, that's what we're looking for. So basically, we just added these two equations up, right? Okay, so now when you do that, we also need to do the calculation for Gibbs free energy. So then simply 34.5 plus the value from equation 1, 49.6. Okay, you do this calculation, the final answer will be 524.1. Okay, so that will be choice number E. Okay, so this type of question, again, you just need to do observation, right? See what you want, how you can get your want from the given equations. Then whatever you do, make sure you do that to your Gibbs free energy, and then the answer is not hard to find. Okay, so this is how you do question number 39, Hess law for Gibbs free energy for the reaction, and then hopefully this is helpful.